So let's continue. So before the break, we introduced comma operators and we introduced most of the thing for the four statements. It have a 3 expression and each expression serve different purpose for the iteration. So it's very important to memorize the purpose of each expression and to know how to use those expressions properly. That is very important. And also check out whether you make one of these common arrows for 4 statements. So after the break, what we're gonna do first, maybe most of you think about, is to the Slido to test whether you guys really understand the 4 statements and the comma operators. So don't be afraid about this program here. So okay. I just use longer variable names, and I use the comma operator. So you can see that we have 2 initialization and 1 declaration for the expression 1. We have 2 expression for expression 3. And we only do one thing in the loop body, that is to print out the latest value stored inside the variable final score. So the question is, what is the printed message of this program? And again, that's wait until we have 35 submissions. Okay, 30 submissions, and then we will check out the result. Okay, so let's check out the result. Very good. So over half of the submission choose the correct one. So yes, this is the output of the programs above. So let's check out why. So the output is start from 0 and end at 5, right? And some of you choose phase 1. So let's check out why the printed value is start from 0 instead of 1. So here you can see we have 2 variables here, that is score per task, and then total number of tasks is 6. And for the first expression, for the for loops, that we declare 2 variables for for loops, right? That is the number of tasks. So I use this as the counting variable to count how many tasks we have add so far, and this is the final score, that is the total score of the task, and I also use printf to print out the value stored inside this variable final score. And then the controlling expression is that I will continue the loops as long as the number of tasks is less than total number of tasks. So the value stored inside this variable is 6. So as long as the value of number of tasks is less than 6, I will continue the loops. So after we evaluate the first expression and the second expression, we need to run the loop body first and then go back to the expression 3. So that is why after I finish the second expression, I need to jump to the loop body here. And then I just print out the current value I have for the final score. So the current value of the final score is, of course, the initialized value here, I used to initialize final score. So that is why the first output is 0 instead of 1. So if you choose 1, maybe you forgot that you need to run the loop body first, then go back to expression 3. So when the loop body was firstly run, we haven't run expression 3 yet. So that is why the output, the printed value of the final score is start from 0. And then start from 0, and then we go back to the expression 3. So number of tasks increment by 1, and then the final score, we just add the score per task to the final score, and then update the value of the final score, and then go back to the controlling expression. So you can try to chase this loop by yourself if you still not sure why this is the correct answer. Okay. So let's continue the next part of today's course. So we have introduced the previous 2 categories of C statements. We introduced selection statement, if and switch. We also introduced iteration statement like while, do, and for loops. Then the final type of the C statement is jump statements. We have break, continue, and go to. And we already saw some example of break, but today I'm gonna introduce more details about the break. So this jump statement can actually offer us another way to exit from the loops. So the normal exit point, the normal ending point for a loop is normally at the beginning of the loops, like the while and the for loop statement, or at the end, the do statement. So the reason why this is beginning is that we put the controlling expression at the beginning for the for loops and while loops, and the controlling expression for the do statement is at the end. So that is why the exit point of the do loop is at the end. But sometimes we just need a loop with exit points in the middle of the loop body. So if we want these kind of spatial loops, how can we achieve this? So you already see something that can help us to jump from one line to the other section of your program, right? So that is the break statement, and we use the break statement in the switch statement here. So what break statement can help us to do is to transfer the control, transfer the flow of your programs out of the switch. So we just say that you can jump from here to here. So that means that we can jump the programming flow from here and then skip all this line and then jump to here. So that is what I mean by transfer control out of the switch statement. However, we can also use break statement to jump out of while, do, and the for loops. So let's check out how we can use break statement with these loops. So here is an example of the for statements, and I have the break statement here. So what this for statement or what this example want to do it here is to check whether a number n I have here is a prime, is a 质数. So this is a small program to check whether number n is prime. And then we can use a break statement to stop the loops as long as a divisor is found. So as long as we found a divisor, then this is not prime, right? So if we find this value, then there's no point. We don't need to continue the loops again. As long as we found the divisor, we can just break out from the loops. So this is how we can set up this program here. So we have the for loop like this. So we start from D, so D stands for the divisor, and N is the value we want to check whether this is prime. And then we just increment D by 1. And then inside the for loop body, I just have one if statement to check whether the current value d can divide n without having any like remainder value. And if it is true, that means that n is not prime. So if as long as we find that this is true, then the statement for this if statement is break, then we will just break out from the for loops and then jump to the next line after the for loops. So you can see we have another selection statement to test whether if d is still less than n, so that means that this d can divide n. And if d is not less than n, that means that n is prime. So this is one example of how to use a break statement with for loop. So this is another example of how we can use a break statement to set the exit point in the middle of the loop body rather than the beginning or the end. So this can save some works because as long as some situation is true, sometimes there's no need to run the other statement in the loop. So in these for loops, in these while loops, what we did is that we want to write this program to let user continue to add number in these while loops, and then we want to set up one like special command for this loop. As long as the user enter this special number in these while loops, then my program want to just break from the while loop. So I don't want the users to enter the data anymore. So this is how we can set up a for loop like this. So let's assume that the terminate command for this example is 0 here. So in these while loops, what I define is that user can enter any number inside this and to calculate the cube like this. And I have a special comment right here. So if the user want to stop this like enter value process, they can enter 0 to stop these loops. So to do that, I can write down a if statement to check out whether the input value is 0 or not, and if it is true, I need to exit this loop. So that is why I have a if statement here, and I put break inside inside this if statement. So as long as user enter the number that is not 0, user can continue input the data and get the qubit value in these while loops. So that this is the statement that these while loops will do. So this is one example why we need a break statement. It can make your program more flexible. So, but there's also some limitation for the break statement here. So what the break statement will do is just to transfer the control out of the innermost enclosing while, do, for, or switch. So when we have like nested structure like this for while loops, this switch statements is nested inside the while loop, and I have a break here, then what will happen is that the break statement can just only help us to jump one level of nesting here. So in this case, the break statement inside the switch statement just help us to jump out of the switch statement. But since we already have one inner layer, inner braces here for the switch statement, and so I just jump out from the switch statement to here. But what is important is that even for this line, this is still inside the while loop. So this break can just jump one level of nesting structure. If you want to jump out from the while loops, you need to have another break to jump out from the while loop. So it's very important to know this special feature of breaks here. So the breaks here doesn't mean that you can just jump all the way out from the while loops. You can just jump one level of nesting. So this is important things. So let's just quickly check out whether you understand what that means by just jump by one layers of the nested structure. So here we have exactly the same structure here. I have the while loops here, and I have the switch statements inside the while loop, and have break here, right? So what this program can do is that depends on the input number from users, the program will just calculate different things. And then I have the final printf to say this is end of the program here. So the question is that what will be the first output message? What was the first line what was the first line of the printed message after user input number 4? So user just input 4 here, and then for the 4 here, what will happen? Okay. I know you guys know the answer. Sorry about that. But let's wait. Maybe some of you didn't check out the presentations. Okay. So let's check out the result. Okay. So the first printed message after user input 4 is this. So the output information is enter a number. So I just find out this is a bit different from this one. Sorry about that. I'm not sure why I forgot to add a break and a printf here. So we should check. We should use this one instead of this. So let's trace this code one by one to see why the first message after user input 4 is this one instead of the end of the program here. So in this case, when the user enter 4, the 4 will be stored inside n, right? Then we go to switch. Then switch will check out the value of n to find the match case here. So since there's only 1, 2, 3 in the case here, so when the user input 4, we will go to the default case. And the statement in the default case is break. So we'll just break from the switch statement. But just like what we mentioned here, we just break one level of the nesting structure. So the break will just jump from to here. So it will still inside the while loops. So then so there's nothing in this line. So we just go back to the while loops. And since we put 1 here, so the while loop will always will continue, repeat, it will always be true. The controlling expression will always be true. So after we jump to this, the first printed information will be what we have in the printf here, that is enter a number. So that is why the correct answer for this Slido is enter a number here. Okay, so after we introduce break, then let's introduce another jump statement that is continue. We have break, and we of course have a continue. So what continue help us to do is to transfer the control of the program to the point just before the end of the loop body. So what continue can help us to do is to skip the statement between the continue statement and the end of the loop body. So when we use continue, the control will still remain inside the loop, so we will not jump out from the loops. But what we can do is to skip all the statements between the end of the loop body and the continue. And so that's the continue statement. You can only use continue statements for any loops, for the loop statement. So you cannot use the continue with the if and else statement or switch statement. You can only use continue statement with any loop statement. So here is the example of how I can use continue. So again, we have these while loops and I have a continue here. So in this example, I have the n, sum, and I will want to add I to sum until I reach the value until I reach 10, then I will stop the loops. So the control expression is that I will just check whether n is still less than 10. Then if it is true, I can allow the user to enter one number and then store the number to I, and then just add I to sum, and then just increment n by 1. So what this program can do is to allow user to enter 10 number, and the program will sum the value that user have entered. And in this case, I put the if statement here, and the reason is that I don't want to count the 0 as a valid input number in this case. So if the user enter 0 here, I want to just skip this to continue to let the user enter other value that is not 0. So how to do that? So in order to do that, I can put an if statement here to check whether the input value is 0 or not. And if it is 0, then I will run the continue statement here. So just like I have mentioned in this slide, what continue statement can help us to do is to skip the statement between continue and the end of the loop body. So that is why when the continue is evaluated, the control of your program, the flow of your program will jump from here right away to this line. So these two statements will be skipped. So the n will not be incremented by 1, I will not be added to sum. So we'll just jump here, but it still remains inside the loops. So after the continue, the next things your program will do is just to go back to the while and then do the same thing again. So this is what we can use for continue. So again, let's quickly check whether you understand what continue can help us to do. So in this program here, if the I is still less than 5, then I will just run continue. I don't want to print out the value that is less than 5. So what will be the printed message of this program here? So actually I just talked about, I just give you the answer. So you should be able to choose the correct option. So let's wait until we have, because of the time, let's wait until we have 25 submissions. Okay. Oh, interesting. Okay. So the printed message is actually this instead of this. So the reason why this is the correct answer is that, we put a less than 5 here. So as long as I is not less than 5, because 5 is not less than 5, right? So when I reach 5, then I will not, the if statement will be false, then I will just print out the value of I. So that is why the printed message will start from 5 instead of 6. Okay. So the final jump statement is the go-to statement. So you can see that the break and continue statements, the place these two statements can help us to jump to is really restricted, right? Because break is jump to the point at the end of the loops, and continue is jump to the point, to the line, before the end of the loops. So if you want to determine where you want to jump to, you can use the go-to statement. So the go-to statement can jump to any lines, any statement in the same function with a given label. So here is the general form of the go-to statement. So you just write down go-to here and just to indicate where your program wants to go. And then you need to put your identifier, your label in somewhere in your code in the same functions. So that's when the program runs go-to identifier here, then your program will transfer the control to the statement to where you put the label at. So let's check out one example here. So this is the go-to version of the program to test whether n is prime. So I can just write down go-to, and I have the label code down, and I put the label here down at here. So you need to write down the label exactly as the same as we have here, and then put the columns here. And then when we run this line, then the program will jump from here to here, and then run the following things. You can also put down to here, then the program will jump from here to here. So the go-to statement is actually rarely used in the everyday C programming, and the reason is that you can make your program flow become very hard to predict, right? Because you can jump to anywhere you like. But sometimes go-to is helpful once in a while. For example, if you want to break from the switch and while loop at once, break from a nested structure, then you cannot use break because break can only exceed one layer. But if you use go-to can just go to anywhere you put the label to. So go-to is a useful statement to exit from a nested loop. Okay, so an important reminder here. So there's no physical class next week. So please watch pre-recorded video on E=2. That will be the basic type 1 and 2, and I will post the announcement. So because I know watch pre-recorded video is faster than the physical class, so I will recommend you to use this time to start your final project and finish the homework one. So that will be all for today, and thank you for coming.